Alright, hey class. So this video is going to be on substitution. Substitution is a way to solve a system of linear equations. There are three ways. One is graphing. The second one that we're working on right now is substitution. The third is elimination. So we have a quiz coming up. So this video is going to be to help you prepare for that quiz. I'm going to go through one quick example. There are three different ways three different solutions. You could have one solution, you could have no solution, and you can have infinitely many solutions. I'm going to go through a quick example on this will turn out to be one solution, and we're going to see why. So on the screen you should be able to see the steps in order to solve a system of linear equation by substitution, and I'm going to go through those steps. So the first one is you are going to substitute one equation into another equation. Now the equation that we're substituting is this one. It's solved for. It's saying y is equal to a bunch of stuff. I'm going to substitute what it's equal to. In this case, it is 4x plus 10 into the other equation. So wherever I see y, okay, I see a y right over there, I'm just going to write 4x plus 10. So let's do that. Okay, so I'm going to rewrite this. I'm going to rewrite this using now this equation. So I'm going to put 7x plus 2, but I stop right there because I have a y. Well, we're going to write what it was equal to. In this case, it is 4x plus 10. Okay, I just continue writing the rest of the problem down. So equal to 19. Notice how the only thing that changed was y. Y is 4x plus 10. And we can say that they're equal to by this other equation. Okay, now the second step after that was that we're going to distribute. We can see that we have 2 over here outside the parentheses, so I'm going to distribute that 2 to everything that's on the inside. So, well, first off, the reason that we substitute is because we want only one variable, and the one variable that we have is x. We want to solve for that. But let's distribute. So we have negative 7x, positive 2 times 4x is a positive 8x, and positive 2 times 10 is a positive 20, and that's equal to 19. Now we want to solve for x, and I've kind of put the steps on the screen just so it can be, it's very transparent what you need to do. So we've distributed. Now we need to combine like terms. Well, I see a like term. We see that we have negative 7x and positive 8x. That's going to give us negative 7 plus 8. That is just 1x, or I'm just going to put x. Okay, we're going to add 20 to it and set it equal to 19. Well, since we're going to solve for x, I believe that's step 4. I need to get rid of this positive 20. We do the inverse of it. We're going to subtract, right? So this goes away. We're going to have x equal to 19 minus 20 is a negative 1. Alright, so at this point we find what x is. We need to find what y is. My ultimate goal is to get an ordered pair of x comma y. We have our x, it's negative 1. The way that you find it is I plug in this negative 1 into an equation here. Overall, I should get the correct answer, but it's very easy. It's easier if I substitute it into this solved equation, this one right over here. So what I'm going to do is I'm going to take this negative 1 and put it right in there. So in a similar sense, I'm substituting again. So I'm going to rewrite this equation, y equal to 4, and in place for x, I'm going to put negative 1 in parentheses, right? Just being safe, being very cautious when I substitute. And over here, let's simplify. Multiplication and addition, I'm going to multiply first. 4 times negative 1 is a negative 4, and plus 10. And here, this gets into basic integers here. Negative 4 plus 10. Different signs, you subtract. That's going to give me a 6. Keep the sign of the bigger number. Bigger number is 10. It's positive. So it turns out that y will be 6. So we're going to have y over here, positive 6. So this means that if I were to graph these two lines to these two equations, they would intersect at the point negative 1 comma 6. So that concludes this example. My advice is that you, whoever is watching this, if anyone is watching this, make sure that you're very diligent, very careful when you distribute, when you combine like terms. All these steps, it's a lot of math, a lot of computation, arithmetic going on. Take your time. Okay, if I were to miss a minus sign, miss a simple number, if I distributed wrong, that trickles down to the rest of the problem. So be very careful when you solve a system by substitution.